Hello, welcome to the Master Camp programming session. So in this session I will show you that how we can do the programming. So first of all I will show you that how we can do the facing program, how we can do the OD turning program, how we can create the OD finishing program. So we have 3D model, right? So we don't need 3D model for lathe programming. We need only 2D boundary of this 3D model. So here I will go to the wireframe tab, and here I will show you that how we can create the 2D boundary from the 3D model. So you can click here, turn profile. So just click on that and select the model, and then you can say end selection and then say OK. So once you will click on that, you will get 2D section profile of this 3D model, right? So as you can see, this is the 2D section profile of this 3D model. I will change the line width, and no, it's okay. So first we will create the facing program. So as you can see, there is 2 mm stock in the right side for the facing purpose. So I will create a line, I will create a simple line, and I will hide this model. I will hide this model from the screen. So I will select these lines, and I will go to the home tab, and I will say hide. So as you can see, this is the 2D boundary which we need for programming purpose. So in the turning cycle, you will get the general cycle. As you can see, there is multiple options available. First one is roughing, finishing, drilling, facing, cutoff. So these are the cycles which we have to use for programming purpose. And here you will get some more option, that is canned cycle related. So if you have to create editable program, if you want to create editable program, so you can use these canned cycles. So multiple option is there. First one is for roughing, OD turning, OD finishing, grooving, and pattern roughing. So these all are the canned cycle, and these all are the general cycle. General cycle means you will get lengthy programs, so that will be non-editable, and this one will be editable. So as per your choice, you can use the both strategies. So first of all, I will show you facing program. So I will select on that, and as you can see, this is the new window. So here we have to define the tool, which tool we have to use. So here you can select, this is R.8 tool. So you can double click on the tool, just do double click, you will get a new window. So these are all the details of that tool that insert. So if you want to customize, you can customize that. You can select here, get insert. So once you will click on that, you will get the library of the insert. So you can select that here. So which insert you need, you can select that from here. So normally we will use CNMG 1204.8. So here you will get the dimension of insert. So if you have to customize it, you can customize that from here. This is the 12, that is insert diameter. This is the thickness of insert. This is the corner radius of that insert. And if you want to customize the corner radius, you can customize that from here. If you need 0.4, you can change that from here. It's very easy to customize. And in the second window, you will get a holder drawing. So if you want to customize the holder size, so you can customize that from here. These are the drawings. A means this width, B means total length. So all the things are available here. So you can customize your holder also. And if you need circular holder, so you can select that from here. If you need rectangular, you can select that from here. Now say OK. So we have selected the tool, and next we have to define that which tool number we have to use. First one, tool number 1, station number 1, offset number 1, fine. And here you will get the feed rate, that is depend on your tool grade and material hardness. So you can fill this as per your tool and material. So spindle speed you will get from here. Spindle speed, this is RPM. So you can give the RPM value here. So you can give the RPM value as per the tool, as per the diameter. And here you can use CSS, that is constant surface speed. So in the constant surface speed, if you select on this option, so you can't give actual RPM here. So you have to give minimum RPM and maximum RPM. So program will generate in G96 and G97. So you will get a different type of RPM as per your job diameter. So your feed rate, your RPM will increase, your RPM will decrease as per the job dia. Okay, so these all are the things which we have to fill after selecting the tool. And here you can customize your home position. So if you want to change, if you want to customize the home position, if you want to start from here, if you want to start from here, so you can change that from here. You can say from machine, you can say user defined. So you can define that from here, select. So suppose you want to start from here, so you can select that. Your tool will start from here and then it will come here, and then say OK. And the next you have to go that is face parameter. So in the face parameter you will get some options, that is select points. So you can select that from here. So we can define that from this point to this point. So we have defined the stock, and here you can define the entry amount, means you have to start from 1 mm above from this face, from the OD face. So you can give the clearance, and here you can give the rough step over, means depth of cut. So you can give 0.8, and here you can give a last cut that will be 0.550 micron, and the number of finish passes will be 1 passes. And here you can give the overcut amount, means suppose you are using 0.8 insert. So if you will not give this overcut amount, so there may be leave some material of the corner radius, so you can do overcut. So we are using 0.8 insert, right? So we can do multiply into 2, so you will get 1.6 overcut from this center. So there may be no extra material or points after facing toolpath. So here you will get a retraction amount. So in every passage you can give the retraction amount, means suppose you have given 0.8 depth of cut, so it will make a first cut and then it will retract. So that retraction value you can give here. And stock to leave option is there. So if you want to leave some stock for finishing purpose, so you can give that from here. And if you don't want, you can make it 0. And these are all the compensation value. Suppose you want to generate your program in where D value, so you can select on this where compensation. So normally we use computer, so I will select that computer. Okay, so we have done this. We have finished this parameter. So now we will say OK. So you can see the stock has been removed by this tool. And these are all the blue toolpath, that is called toolpath. So you can check that in backplot. So as you can see, there is an option for backplot. So I will select on that, and I will limit the speed, and here I will say play. So your tool will move like this. This is the general cycle facing toolpath, and after this I will show you that how we can create canned cycle facing toolpath. All right, it's looking good. Okay, so I will show you the simulation also. I will save this and I will show you the simulation. I will select on this verify option, so it will open a new window for verification purpose. So this is the stock we have defined, and this is the chuck we have defined, and this is the tool we have defined. So I will select on that, and here I will limit the speed and I will play it. So as you can see, the facing toolpath is going on and it's removing the material continuously. Perfect. So facing toolpath has been done, and now we will proceed with canned cycle facing toolpath. So I will hide this toolpath. So you can see this is the blue toolpath. So we can hide that from here. Just select the toolpath and you can say display toggle off. So once more I will show you that how we can create the facing toolpath with canned cycle. So I will create a line like this. So this is the line. Now we will go to the same turning tab, and here we'll go to the rough cycle. So I will select on canned rough, and then we have to define the chain. So I will select partial. Okay. And here you can define here you can select the tool. So I will select this tool. Same tool we will use for the facing. And next you can go to the canned rough parameter, and here simply you have to change this parameter. You have to go in the rough direction, and here you can select the facing direction. So select on that, and here you can say stock to leave 0, stock to leave 0, depth of cut 0.8. Okay. So you can see we have created the canned cycle facing toolpath. So you can see this tool is moving from here because we forgot to change the home position value. So we'll go to the toolpath parameter, and here we will say user defined, define the position from here. Okay, and then say regenerate, and you can say backplot, and then say play. This is the canned cycle facing toolpath. And if you need some more passes, so you can extend this line. I will show you that. I will go to the wireframe tab, and here I will say modify length 1.6 to remove the point, and here I will create a line like this. So you can define that value from here. So suppose you have 1 mm stock or 2 mm stock, so you can select that. So you will get the horizontal line like this, and then you can change the geometry from here. Right click and rechain all, select this chain and this chain, not that. We forgot to change the direction actually, so we have to select this direction and then this direction. All right, so now we'll select OK, and then we'll say regenerate the selected toolpath. So you can see there is showing some cuts. So we have given 0.8 mm of cut. Okay, so you can see 2 passes created with the 0.8 step over like this. So I will show you the backplot also. Backplot 8. Okay, fantastic, done. So we have covered facing toolpath using general cycle, facing toolpath using general cycle, and facing toolpath using canned cycle.